The multiplicity in the last episode that shows root A has odd multiplicity that crosses the x-axis, while root B has even multiplicity that touches the x-axis. But to show the concrete graph, it is helpful to give importance to its turning points. What do you mean by turning points? For even degree function, the graph is in upward position or its sketch from the left side goes down to its turning point, then moving up to the next turning point and slightly moving down to its turning point and moving up again. And vice versa for the downward position or even negative degree. And for positive odd degree, it's like going uphill, turning point, going downhill, then turning point, going uphill again, and vice versa for negative odd degree. So, as we've seen it, turning point occurs when the graph of polynomial function changes from increasing or decreasing or from decreasing to increasing. It is associated with hills or valleys as shown in the graph passing through the points negative 2, 8 and 2, negative 8. It could either be maximum turning point or minimum turning point, as clearly shown. It is also called as global maximum, local maximum, and local minimum. Turning point could also be absolute maximum, relative minimum, and relative maximum. Arrows end no minimum. This approach to negative infinity. Let's try analyzing the graph of a polynomial function. The left side rises and the right side falls. Therefore, a is less than 0, negative, and the polynomial function has odd degree. The graph has 4 turning points. A polynomial of degree n can have at most n minus 1 turning points. Therefore, the function must be at least degree 5. Cool! As what you've learned, turning point is a point where the graph changes from increasing or decreasing or vice versa. Occurs at local minimum or local maximum. Let's check this. How many turning points? Yeah, it's 4. How many local minimum? 2. How many local maximum? You're right, it's 2. How many x-intercepts where y is equal to 0 or points that passes through the x-axis? Yeah, it's 3. How many y-intercepts where x value is equal to 0 or point passing through the y-axis? Only 1. Right. the significance of degrees versus turning points in graphing polynomial functions. First, try to observe the given graph. Look at their power or exponent. What is the degree of the function y shown in blue sketch? Oh, yes, it's on the fifth degree. Now, let us see its connection in terms of its turning points. Find out how many turning points. It is 4. You're right. What about the function on the fourth degree? Look at the corresponding sketch in red outline. Try to coordinate its into its turning points. The number of turning points is 3. You've seen it? So, what do you observe now? Do you agree that degree n of the function should be equal or greater than 1? Yes, this concept works. The degree n is greater or equal to 1 is at most n minus 1. What do you mean by that? Meaning, the number of turning points cannot be higher than its degree. That's why in the blue sketch of the fifth degree has n minus 1 or 5 minus 1 is equal to 4 turning points. Likewise, the red sketch of the fourth degree obviously has 3 turning points, lesser 1 from its degree, or 4 minus 1 is equal to 3 turning points. Can you still remember this? In the first episode of Graphing Polynomial Functions, are you ready to answer this accurately? Let's start with its degree.
5. Even or odd? 5 is an odd degree.
Could either be A or B, since one is rising and the other is falling, and not upward or downward position as it describes even degree.
The leading coefficient is negative, since one is rising to the left and falling to the right. Therefore, it is letter A.
Is that the same with your choice? I'm glad you've got it. And now, let's check the turning points.
Degree 5, so you expect degree minus 1, and so 5 minus 1 is equal to 4 turning points. Let us check the graph. Is 4 turning points visible in the sketch? Take note that S-like with degree 3 has 2 turning points, plus another S-like in this part equivalent to 2 turning points. So, it is really 4 turning points as seen in the sketch.
Before we start on the task together, can you still remember how to find the x and y intercepts? X-intercept, y is equal to 0, right? For y-intercept, x is equal to 0. Now, let's be ready.
For each given polynomial function, describe or determine the following, then sketch the graph.